Machine learning techniques can basically be classified into four categories as supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Out of these four, supervised learning and unsupervised learning are very common, and the tasks included under supervised learning are regression and classification. Under unsupervised learning, the common tasks include clustering and dimensionality reduction.
So what is supervised learning? Supervised learning is similar to learning with supervision, just like guided by a teacher. So a teacher guides you, or a mother guides a child by showing the pictures or by teaching them. Okay, say for example, this is apple, this is cat, this is dog. So these data are learnt by the child with the supervision. So that is called supervised learning. So here the set of data, the training data, consists of a set of input data and correct responses corresponding to every piece of data. Based on this training data, the algorithm has to generalize such that it is able to correctly or with minimum error respond to possible inputs. In essence, the algorithm should produce sensible outputs for inputs that weren't encountered during training. So this is illustrated here. Let us assume the training text, document, image, sound, okay, from which the features are extracted is given to the machine learning algorithm, and these input, it may be a document or it may be a text or an image or a sound, has a label associated with it. Now when a new text or document or image or sound which has not been used during the training is used in testing phase. So the features are extracted and the feature vector is given to the model. The output of the model is the expected label. For example, let us consider the shapes here, which the data includes a hexagon, it includes a square, triangle, and the name of these shapes, which is called as label, is also given to the training model. So the model knows a shape with 4 equal sides, an enclosure with 4 equal sides is a square. A shape with 3 sides enclosed is a triangle, and a shape with 6 sides is called hexagon. So this prediction, when a test data is given to the model, the prediction gives an output. The algorithm, prediction algorithm or the machine learning algorithm gives an output with the label identifying the shape as square or a triangle respectively. So commonly the supervised learning algorithms can be of two types. One is regression and another one is classification. Under regression, commonly used algorithms are linear regression, regression trees, nonlinear regression, Bayesian linear regression, polynomial regression. And under classification, we have random forest classification algorithm, decision trees, logistic regression, and support vector machines. Now, what is the difference between regression and classification? Regression gives a numerical output, whereas classification gives a categorical output. So the output of classification algorithm may be yes or no, true or false, 0 or 1, etc. Whereas in the case of a regression, a curve or a line is fit to the data as much as close as possible. So the regression, using the regression technique, we can predict a numerical value. For example, the price of a product or the price of petrol could be predicted based on the previous data. So it will give you a numerical output. Next, let us see about unsupervised learning. Now, in unsupervised learning, there will not be any information about the correct outputs. It is not a regression, no guesses about the function can be made, and no information about the classes also can be done. But if we design our algorithm so that it exploits the similarities between inputs so as to cluster the inputs that are similar in pattern, similar in characteristics, then we might arrive at a classification output. So in essence, we can say the aim of unsupervised learning is to find clusters of similar inputs in the data without being explicitly told that some data points belong to one class and the other in other classes. So the algorithm has to discover the similarity by itself. Now, if you compare this figure with the figure of a supervised learning, we can see the label is missing here. So the input, training input consists of text, documents, images, sounds without any label. And the feature vectors are extracted and the algorithm learns the feature vectors. So it identifies feature vectors of a particular group, cluster them, and assigns them a label, class 1, class 2, etc. When you give a new test image or a document, feature vectors are extracted and the model based on the learnt algorithm, it will predict to which class it belongs to. With an example, we will see here, we have unlabeled data of cats and dogs. So since we know already like these are cats and dogs, okay, we are telling it by name cats and dogs, but assume we don't know what it is. Okay, so a child who is new to learning about animals, to identify whether it is a cat or a dog, okay, so here without any label, these data are given to the algorithm and the algorithm will group all the animals which are similar in character or pattern or feature as one class. So all the cats will be grouped into one class and all the dogs will be grouped into another class. So the output after processing will be two classes, one class of similar animal, another class of similar animal, which can be later labeled as dogs and cats. So some of the common unsupervised learning algorithms are k-means clustering, KN and K nearest neighbor, hierarchical clustering, anomaly detection, neural networks, principal component analysis, independent component analysis, a priori algorithm, and singular value decomposition.
Another category of machine learning technique is semi-supervised learning. It is an important category that lies between the supervised and unsupervised machine learning. In supervised learning, all data is labeled, whereas all data is unlabeled in unsupervised learning. In semi-supervised learning, a small portion of the data is labeled and lots of data are unlabeled. Let's identify the difference between supervised, unsupervised, and semi-supervised with the following diagram in a nutshell. In supervised learning, all the data is labeled and it is given to a model for training. While in semi-supervised learning, small portion of the data is labeled and lots of data are unlabeled, and this is used to train a model. While in unsupervised learning, all the data is unlabeled and these data are used to train the model. Let us see what is reinforcement learning. Reinforcement learning is a subset of machine learning. Reinforcement learning is a feedback-based machine learning technique in which an agent learns to behave in an environment by performing the actions and seeing the results of actions. For each action, the agent gets positive or negative feedback. For each good action, the agent gets positive feedback, and for each bad action, the agent gets negative feedback or penalty. Reinforcement learning has four essential components. They are agent, environment, action, and rewards. Agent refers to the program you train with the aim of doing a job you specify. Environment represents the world, real or virtual, in which the agent performs actions. Action refers to a move made by the agent which causes a status change in the environment. And rewards represent the evaluation of an action which can be positive or negative. The process of reinforcement learning is shown in the diagram given here. The first step involves observation of the environment. The second step involves deciding how to act using some strategy. The third is acting accordingly and then receiving a reward or penalty. The next step is to learn from the experiences and refine our strategy, and finally iterate until an optimal strategy is found.